We're going to look at number 1 and 2 together. They're similar ideas, but they're kind of checking slightly different concepts. When you're trying to figure out if a compound has more entropy than another one, you remember that all compounds have entropy unless they're at absolute zero. The entropy comes from their movement. It comes from the bonds wiggling or squishing, as well as rotations around them. And all molecules have that. But what distinguishes them is, you remember, it's the number of microstates that they have. In other words, the number of different ways they could squish. This one could be short, that one could be long at any one particular moment. So there's a lot of microstates there. A, though, down over here, and you notice I'm looking at two examples, A and E from this problem. A has more bonds, so it has more possible ways that they could vibrate, rotate, so they have much higher entropy. So if you understand that sort of thinking, then you can probably sort these. Now, down in number 2, they're going to get to some other ideas, and not just size of compounds, which I think is what they're testing in 1. They're also getting to states. And so you might ask yourself, do you think a gas or a solid will have more entropy? And you remember that entropy comes from wiggling motion. Which one of these two would have more wiggling motion? And then you might also think about, I see here peeked down the bottom of the screen, an ionic solid. And you remember, ionic solids are those ones that are packed really tightly in a lattice, where it's positive and negative and positive and negative. So do you think that's going to have really high or low entropy? So if you think that through, I think you'll be fine. If you have two molecules that are similar size, or where size is a differentiator and state, I think the state is definitely going to override it. If one's a gas, that's going to have a huge impact. But you can try them out and see if you can figure out the order.